Welcome everyone to part 2 of lesson 2. In this video we're going to be setting up a very basic network between two computers, and what we're going to do is we're going to make one of the computers into a server, which means that the one that's a server will be listening out for those GET requests that I mentioned in the first video. And when it gets a GET request, it will send the file from its data or from its storage to that computer which is requesting it. So we're going to use here a sort of a notebook, a laptop, to represent your computer, the one that's going to request the website, and we're going to use a desktop PC as a server, and then we're going to connect both of them with a wire like this. So these are in a wired network. We mentioned this in the first lesson. There are wired and wireless connections. This is a wired connection. It's a direct connection. So let's just rename a few of these. We're going to say home computer, and then we're going to double click on this one, and we're going to name this as the server, just so that we can have a bit of visual representation of what these computers are going to do. Now, what I'm going to do next is I'm going to set up the addresses, the IP addresses. Now, don't worry just yet about what these are. I'm going to explain those a little bit later. But for now, what's important is that you can just see how this computer over here, the home computer, is requesting a file from the server. So I'm just going to change the IP address. Again, don't worry about the fact that you don't understand it. We'll get into that a little bit later. So what I'm going to do next is I'm going to run my simulation, and I'm going to open up my home computer and my server. So let's have them side by side here so we can see what's happening. So the server is the virtual operating system for this icon over here, and the same thing for the home computer. It's a virtual operating system for the home computer. Now, on the home computer, we are going to install a web browser. So this is no different from your web browsers at home. For example, your Firefox, your Opera, your Chrome, your Edge. This is what a web browser is. You use it to browse websites on a network. We're going to apply the changes, and it's going to install this web browser over here, which sort of looks like Firefox, but it's a WaterFox. So it's called WaterWolf browser, and we're just going to leave it like this for now. We are going to go to the server, and we're going to install the program for the server. Everything on your computer that does something is a program. So we're going to install the web server. We're going to start the web server here. So now that I've started the web server, you can see here it says start accepting connections, which basically means it's going to accept from now on requests by other computers so that it can serve its files. So if I go over to my home computer, we're going to enter the IP address for this server. And we're not going to enter a website name like a URL because we haven't attached a domain name to the server. So we can only access it using its IP address. So if I type the IP address 192.168.0.11 and press enter, or I'm going to press start on the web browser, what you're going to see is this wire between the two computers is going to start lighting up. So it's going to turn green, and it's going to show you that this computer, the home computer, is communicating with the server, and the server is then sending the files back to the home computer. So I'm going to press start. There we go. Now, on the server, what you can see is some information about an IP address for a computer which requested something from the server. So you can see here .0.10 is the IP address for the home computer. And it's saying that it has established a connection with it, and then it got the GET request from for the file, and then the host, which is the server. Remember what host means. When you have guests in your house, you are the host, you are hosting them. So then this is all of the information that it sent to the home computer. Now again, don't worry about the fact that this information seems very, very random. And you can see here it's closed the connection, because leaving connections open takes up a lot of resources. So once it's sent the file, it doesn't need to keep the connection established anymore or open anymore. Now, what we can do here is we can add another computer. So if I just close these for a second, I'm going to stop the simulation, and I'm going to add another computer here. So what we're going to say is, we'll say home computer, and then we'll add this one as the, let's say for example, kids computer, like so. And now we want to attach both of these computers to the server. So what we need to do here is, I'm going to remove this cable, and we're going to use something called a switch. Don't worry about what this is at the moment. I'm just going to show you what happens with these connections. So I'm going to run the simulation next. I'm going to open up the kids computer and install a web browser on it as well. Apply the changes. Now, what I've done wrong is I've made the kids computer the same IP address as the home computer. So that's going to cause a clash. So I'm going to change it to something else, and then run the simulation here. And then I'm going to run the web browser, and I'm going to enter the IP address for the server. If you don't remember it, here it is, 192.168.0.11. And I'm going to press start in a second. Now when I press start, what's going to happen is all of these three wires on the network are going to light up, because what's happening is when I send out this GET request for the first time, this computer, the kids computer, is going to search all of the devices on the network to see where the IP address exists, because it doesn't know yet. It's a new computer we've connected to the network. So if I press start now, you'll see all of the wires light up, because the kids computer is looking for the server, and it doesn't know where it is, so it's going to search every device that is connected to the network. So let's look at that in action. So I don't know if you caught that very quickly, because it just lit up once. It contacted the home computer just to check if that was the correct IP address, and obviously it received you can say a false answer in return, and then it continued the connection with the server because that was the correct IP address. And if I press start again, so I'm going to search the network for this IP address again, the home computer wire won't light up anymore, because now the kids computer knows where the server is. So when we talk later about what IP addresses are, this is how the internet, the world's biggest network, works. It's by constantly learning where devices are using their IP addresses, and once those IP addresses are in memory, then the connection is very quickly when you request something from those devices. So if I press start again, the home computer wire should not turn on again. And there we go, it did not light up, only the connection between kids computer and the server turned on. So if we talk a little bit about these IP addresses, let's end the simulation. So if we have a look at this IP address here, and we look at the net mask over here, right? We're going to, let's write all of this in PowerPoint here, and then we'll explain it a little bit better. So the IP address here was 192.168.0.12 for the kids computer. And the net mask, we're going to write the net mask down here, was 255.255.255.0. Now let's have a look at the IP address for the home computer. If we go back to Filius and click on the home computer, we can see that the IP address is pretty much the same except this last number. Now I invite you to think about why that is before I give you the answer. So while I'm writing this IP address, think about why that last number has to be different, and when I give you the answer, you can check, you can assess yourself to see if you got it right or not. Now, if you thought about an answer, let's check if it was the correct answer. The reason why these last numbers here have to be different on an IP address for these devices is because on the net mask, this number right here is 0. Now, to explain how that works, if we look at these two houses on this picture, they are on the same street, and the street or the road is called Berners-Lee Road. Now, if we write the address for these houses, what we can write here is, for example, let's do it for this one and this one. So we'll say the first house is 1 Berners-Lee Road, and then you'll have, for example, let's say London, and then we'll say, for example, N17 3QA, right? Now, if you write the address for the second house, most of this is going to repeat itself except for the number on the door. So that will be 2 Berners-Lee Road, London, and then N17 3QA. I'm just writing it quick like this so we don't waste time. So both of these two addresses, house addresses, are the same except the number of the door which is used to access the individual house. So to access this group of houses, we need all of this information, which is the same in both addresses, and then to access the individual houses, we need the door number. The same thing for these IP addresses. Because this net mask is 255 in these points here, then the part of the IP address which matches those points has to be the same in both IP addresses, except for the number at the end which is going to differ, because that can't be the same. If both of these two houses have the number 1 in their front doors, then the postman is going to be confused. And the same thing on a network. If both of these IP addresses were the exact same, then the files that are being requested will get confused about where they need to go, which device or which computer they need to go to. So the way IP addresses work is by identifying each computer on a network using a unique IP address, but part of that IP address has to be the same in some sections of it in accordance to something called a net mask. Okay, and in the next section we're going to be looking at some more complex networks which are going to be in different locations. So the network we have seen right now, this would be in the same location. So this would be considered a local area network. This is what we learned last lesson about different types of networks. This is a LAN, a local area network. See you in the next part.